There's a star not far from here that should not exist. When astronomers first measured its age, they arrived at a number that broke the universe. The star, they calculated, was older than everything. Older than the galaxies, older than the first light, older than time itself is supposed to go. It was a result that could not be true, and yet there it was, burning quietly in the constellation Libra, 16 billion years of impossible history written into a single point of light. Tonight, we're going to sit with that impossible star. We will follow the mystery of how something could appear older than the cosmos that made it, and how, in the end, the contradiction was gently resolved, but not before it forced astronomers to question the age of the universe itself. So settle in. Lower the lights. The star has waited a very long time. It can wait a little longer. To understand why this star is so strange, we first have to understand how astronomers read the age of a star at all. Because a star does not carry a birth certificate. It carries something better, its chemistry. When the universe was born, it made almost nothing. Hydrogen, a little helium, a trace of lithium. That was the entire menu of creation. Every other element, the carbon in your body, the oxygen you are breathing, the iron in your blood, none of it existed. All of it had to be forged later inside stars and scattered when those stars died. So the very first stars, the ones born in the young universe, were made of almost pure hydrogen and helium. They are chemically empty. Astronomers call them metal poor. And the emptier a star is, the older it must be. This star, its formal name is HD 140283, though the world came to call it the Methuselah star, after the oldest man in the Hebrew scriptures, is one of the emptiest stars ever found. It has less than 1% of the heavy elements that our sun contains. Almost pure hydrogen and helium, the fossil chemistry of the dawn of everything. To an astronomer, that emptiness is a kind of clock. It says, I was here before the galaxies enriched the universe. I was here at the beginning. And so, in the year 2000, using data from the Hipparcos satellite, astronomers made a first estimate of its age. The number that came back was staggering, around 16 billion years. And that is where the universe broke, because we know, with remarkable precision, how old the universe is by measuring the faint afterglow of the Big Bang, the cosmic microwave background, the oldest light there is. Cosmologists have pinned the age of the universe at 13.8 billion years. That number is one of the most carefully measured quantities in all of science. It is not a guess. It is the birthday of everything. And here was a single star sitting quietly in our own galactic neighborhood, apparently 16 billion years old. More than 2 billion years older than the universe that was supposed to contain it. It was as though archaeologists had dug up a human skeleton and dated it to a time before the Earth had formed. Something somewhere was wrong. A star cannot be older than the cosmos. A child cannot be older than its mother. For astronomers, a result like this is not an embarrassment. It is an invitation. When the numbers say something impossible, it means one of two things. Either the universe is stranger than you thought, or your measurement is hiding an error. And the only way to find out is to measure again, more carefully than anyone ever has. So a team of astronomers, led by Howard Bond, turned the Hubble Space Telescope toward the Methuselah star. Their goal was to pin down the one number that everything depended on, the star's distance. Because to know a star's true brightness, and therefore its age, you must first know exactly how far away it is. And distance in astronomy is the hardest thing in the world to measure. The method they used is one of the most beautiful in all of science. It is called parallax, and you already understand it, even if you have never heard the word. Hold up a finger at arm's length. Close one eye, then the other. Your finger jumps against the background. That jump is parallax, the shift in position of a near object against a distant backdrop, seen from two different points of view. Now imagine your two eyes are not a few centimeters apart, but placed on opposite sides of Earth's orbit, 300 million kilometers apart. As our planet swings around the sun across 6 months, a nearby star appears to shift, ever so slightly, against the distant stars behind it. Measure that shift, and geometry hand you the distance. No assumptions, just triangles, the same triangles the ancient Greeks would have understood. Between 2003 and 2011, Hubble watched the Methuselah star make this tiny dance again and again, refining the measurement to extraordinary precision. And the new, better distance changed everything. The star turned out to be very slightly farther away than the old satellite data had suggested. And that small correction rippled all the way through the calculation. Its true brightness, the rate it burns its fuel, the physics of its slow decline. When Howard Bond's team put the new numbers together in 2013, the Methuselah star's age came out to around 14.5 billion years. Still impossibly old. Still, on paper, older than the universe. But now with something crucial attached. An uncertainty of roughly 800 million years in either direction. And that uncertainty is the key that unlocks the whole paradox. Because 14.5 billion, give or take 800 million, means the star could genuinely be as young as 13.7 billion years. And 13.7 billion years is younger than the 13.8 billion year old universe. Just barely. By a whisker. The impossible star, it turned out, was not impossible after all. It could have formed just a few 100 million years after the Big Bang, among the very first generation of stars to light up the cosmic dark. Not older than the universe, just old enough to have witnessed its dawn. Think about what that means. If the Methuselah star is even close to 13.7 billion years old, then it formed when the universe was in its infancy, a few 100 million years after the beginning. The galaxies as we know them did not yet exist. The Milky Way had not yet assembled. This star predates our galaxy. It is older than the Sun by more than 9 billion years. It was already ancient, already burning, when the cloud of gas that would become our solar system was still drifting formless in the dark. Everything you have ever known, every civilization, every dinosaur, every ocean, the entire 4.5 billion year story of Earth, all of it fits inside the second half of this one star's life. It was old before our story even began. So how did an ancient star end up here, drifting through our cosmic neighborhood? The Methuselah star does not belong to the flat, spinning disk of the Milky Way where the sun lives. It is a visitor from the halo, the vast, spherical cloud of ancient stars that surrounds our galaxy like a swarm of old ghosts. Astronomers believe it was likely born in a small galaxy of its own, in the early universe, a galaxy that the growing Milky Way later swallowed whole billions of years ago. The Methuselah star is a survivor of that cosmic cannibalism, a refugee from a world that no longer exists. Right now, it is simply passing through, plunging through the galactic disk at over 1,300 kilometers every second on a long, lonely orbit that will eventually carry it back out into the dark halo it came from. The star itself is not much like our sun, not anymore. It has left its stable middle age behind and swollen into a subgiant, a star in the slow act of dying, beginning to expand and cool as the hydrogen at its core runs low. It is a little more massive than the sun, but it burns with an ancient, careful light. And it is faint. From Earth, you cannot see it with the naked eye. It hangs in the constellation Libra, the scales at around the 7th magnitude, just below the threshold of human vision. You would need binoculars and a star chart and a great deal of patience to find the oldest known star in the sky. It gives away nothing. It simply burns, as it has burned since almost the beginning, indifferent to the small blue world that finally learned to measure it. There is something humbling in how this mystery was solved. The Methuselah star was never actually older than the universe. The paradox was never real. It lived the whole time inside the fog of measurement, inside those error bars, those humble little phrases, give or take 800 million years, that scientists attach to everything they claim to know. The lesson the star taught was not about cosmic impossibility. It was about humility. The universe was not broken. Our knowledge simply had edges, and the star was sitting right on one of them, daring us to measure more carefully. And when we did, with a telescope in orbit, with the geometry of ancient triangles, with years of painstaking patience, the contradiction quietly dissolved. The child was not older than the mother. We had only misjudged by a little how far away the child was standing. And yet the deeper wonder survives, fully intact. Somewhere above you, right now, there's a star that has been burning since the universe was young. It watched the first galaxies condense out of darkness. It was already impossibly old when the sun was born, when the earth cooled, when the first cell stirred in the first ocean. It has outlived a galaxy. It will keep burning, in all likelihood, long after our own sun has swelled and faded and gone dark. It asks nothing of us. It does not know we exist. It is simply one of the first lights ever kindled, still lit, drifting through the halo of the galaxy on a journey that began before there was anyone to watch it. So tonight, as sleep comes, let this be the thought you carry into it. The oldest thing you have ever heard of is not a monument, or a mountain, or an ocean. It is a faint point of light in the constellation of the scales, a star that was already ancient before the Earth had a name, before the Earth had anything at all. For a few years, it seemed to break the universe, and in the end, it only taught us to measure more gently and to hold our certainties a little more loosely. It has been burning for nearly 14 billion years. It will still be burning when you wake. And on the scale of its long, patient life, the whole of human history is not even the space of a single breath. This has been the silent cosmos. If these quiet journeys help you rest, there are more waiting for you on the channel. New stories every week. Until then, sleep well beneath the oldest light in the sky.